Welcome to the first session of the training in quantum technology for policymakers. My name is Oksana Mishina, and I am going to be your contact person further on for the training session. I work at the Italian National Institute of Optics, and this partner of Coordination Action for Quantum Flagship is coordinating this training. Let me also share with you that team that helps and coordinates all together this training from the CNRINO, which is Professor Costanza Toninelli. She's an experimental physicist. So me, who was a theoretical physicist, and now I contribute to the workforce building and outreach for Quantum Flagship. And Diana Tartaglia, who is a master in physics and now is doing PhD in quantum technology and studying on the impact of the outreach. This training This training is offered by the Quantum Flagship and was designed together with some members of the European Commission to help satisfy their needs. And I would like to thank hereby the members who helped us to design it, and also all the members of the QCATS, which is the name of the Coordination and Support Action for Quantum Flagship. In this training, we would like, and we plan it such that you gain knowledge to take informed decisions, and then it will help you to cooperate with peers from other countries, and also to sustain conversations with QT experts on the topics. Today, with the start of the summer, we will start also training, and it will be monthly, such that every month you will have one session. So we are starting with the view on the European scene in the quantum technology. And the next month, you will complete the picture with the efforts and investments beyond EU. Then we all go to the summer break in August. And in September, we start diving deep into the use cases and sensing, metrology, communication, and computing sectors. And the final session, the Christmas one, will be about the state of the art in research and development that will anticipate you the future use cases. And now I'm very glad and happy to present you my colleague for the QCATS project and the moderator for today's meeting, Lydia Sanmartí-Vila. She is a knowledge and technology transfer outreach coordinator at the ICFO, which is Catalan Institute for Optics and Photonics in Spain. And currently, she is also an executive director of the European Center of Outreach in Photonics, ICO. And she manages also the project Carla, which is a pan-European career camp that has been in photonics, but since this year also became in quantum technology. And also, she is the manager for the QCATS project at ICFO. Among all her projects, which I would not have time to nominate, even if there would be the whole meeting, I would like to highlight that she's also active in equity, diversity, and inclusion, and she's chairing the working group in EDI in Quantum Flagship and the thematic committee of the Quantum Coordination Board. And last but not least, she got a master in biochemistry and a doctoral degree in neurology. And welcome to the stage, Lydia. I am very happy to have you here with us today. I'm sorry, the microphone is still muted.
Okay, now?
Now it's great.
Sorry. So, thank you very much for the introduction, Oksana, and for inviting me to moderate today's first session dedicated to set up the framework of quantum technologies in Europe. To do that, I believe there is no one better than Professor Tommaso Calarco, and I would even say that there are very few people that have helped shape the European quantum ecosystem the way he has. Professor Calarco has had a very prolific academic career, developed at different important European universities and research centers such as University of Ferrara, University of Innsbruck, the BEC Center in Trento, and the University of Ulm. Currently, he's the director of the Institute for Quantum Control of the Peter Quinberg Institute at Forschungszentrum Jülich and professor of quantum information at the Institute of Theoretical Physics of the University of Cologne. This is in regards to his personal academic career, but as I mentioned, Tommaso Calarco has and is dedicating a very important part of his time to the quantum community. In 2016, he authored the Quantum Manifesto, which initiated the European Commission's Quantum Flagship Initiative, and is currently the chairman of one of the Flagship's governing bodies, the Quantum Community Network, QCN, together with which he launched an initiative which has led to the currently well-established European Quantum Industry Consortium, QUIC. With this, let me pass the floor to Professor Tommaso Calarco, who will have 20 minutes for his presentation. And after that, there will be 15 minutes discussion session, and we will close with a summary of the day. Please write your questions via the Q&A window, which you can find on the right-hand side of your screen. There are like probably 3 dots, and then you can activate the Q&A window. Write there your questions, and I'll read them after Tommaso's presentation. Thank you very much.
Thank you very much. I'm really delighted to be here. This is a very special, I think it is the first time that we have this kind of discussion specifically for policymakers. And this is, as a matter of fact, in the long tradition of our officers and essentially the whole hierarchy in DG Connect being very much engaged with the community in terms of, being passionate about understanding and getting the background and really appreciating what is the content of this quantum technology. So this is what I'm going to try to summarize in a few minutes. So my task I was given was to sort of describe a little bit the ecosystem and also some elements of the roadmap that we're having. And of course, I cannot go into details for that in 20 minutes, but I will give several elements which should help and also references for potential future deepening of these topics. So I hope that you do see my screen. So can anyone nod if that is the case? Yes. Perfect. Fantastic. Thank you. Okay, so let me go right into that. So from the point of view of policy at European level, that we are now in the digital decade. So there was a communication from the European Commission a couple of years ago in which several measures are being conceived, and we will discuss some of them. But important is that very prominently at the level of infrastructures, computing is one challenge in which quantum computers are foreseen at really the top level of the strategy of the European Commission for digital technologies, in particular the idea of getting a first computer with quantum acceleration. But of course, this is just one of several topics which are part of our quantum flagship. So the goals of our quantum flagship is really to start from the scientific excellence that we have in this continent, but really starting a competitive European industry in order for Europe to become one of the leaders in this field. And you will see that in my summary, I will show that we are already reaching some of these important goals. And this is somehow being articulated in different fields, in different directions. So the areas of our flagship, they rest on a sort of a strong foundation of basic science, as you can see here, which is among our scientific and technological resources for developing those applications in terms of application areas in communication, computing, simulation, sensing, and metrology. And I will give a couple of details about what they are in the following. But of course, this is the research part in Horizon Europe, and it also feeds into the infrastructure part in Digital Europe, and we will also discuss that briefly afterwards. So here is a copy and paste of a slide that I presented at our kickoff 5 years ago in the Vienna Imperial Palace when we started in 2018 the project of the flagship. And I am doing copy and paste not only because, of course, I'm lazy and I don't want to have to write my slides, but for a perhaps more important reason, which is that we had a long process and we are still having a process of updating for our strategic research agenda. And it was very important since the beginning that we make promises that are credible. They should be audacious, but also, reachable. And in fact, I am pleased, and you see here, we will go into a little bit of detail for all of these areas afterwards. I am pleased to see that, as a matter of fact, there is almost a one-to-one correspondence to what we have achieved, and we have verified in the cluster review meeting that we had last year in Paris, in which essentially all the projects have reported the outcome of those activities. And indeed, we have, in most cases, achieved the goals, and in some cases even went beyond. For instance, just to highlight one aspect, we achieved practical quantum advantage, so not just quantum supremacy, in which a quantum computer outperforms a supercomputer for a problem of sort of purely artificial interest, in sense of some problem which is constructed to enable this, to make sure that there is this gap, but already in some problems which are of scientific interest and point towards further applications, for instance, in this case in the development of new quantum materials. So in each of these areas, as you can see, we are having, important outputs, including on the industrial side, because we do have startups which now start commercializing those quantum computers, and we are already implementing that in terms of the infrastructure that we are having in quantum communication, in quantum computing. Also in quantum communication, we have startups which indeed are providing such activities, some such devices which can be purchased. And of course, this also is really being connected at the infrastructure level, as I will outline in a few moments. So essentially what we have here is, a couple of basic technologies. So I was asked, because, some of you are not familiar with quantum technologies, even though many of you already are. So in a word, I will say quantum technologies are about manipulating individual quanta, individual photons, individual atoms, individual electrons, and manipulating information, processing information, communicating information, and measuring physical quantities with metrology and sensing in a way which is unprecedented in terms of power, accuracy, and security of communications. In particular, when we speak about communications and we send individual photons here with different quantum states, if some eavesdropper is trying to intercept that due to the laws of quantum mechanics, it will be detected. It will be possible to check that, what Alice has sent here on the left side is not exactly what Bob receives on the right side. And in this way, we can be sure when something has been transmitted in a way which no one has received information about. And it means that this, after steps of quantum validation and certification, we are getting to a secret key, a sequence of random numbers which you can use to encode information. And this may seem science fiction. It looked like science fiction until not long ago, but as a matter of fact, we know that, for instance, in terms of other continents, China already put a satellite with this kind of encryption in orbit. So this has been realized. They also have a network consisting of several segments connecting Beijing, Shanghai, and other cities in China. And of course, this is something which we are also going to develop in Europe, in terms of, here is just a snapshot of my own country, in Germany, where we are creating the German part of EuroQCI, but this is just one example of many other, essentially almost all of the countries of the European Union in which such nodes of the European quantum communication infrastructure are being created. And I will come back to that towards the end of the presentation. Of course, this is, and here you see on the upper right, a QR code which you can use to get information about our strategic research agenda. So the way in which the whole community, here is a not updated snapshot, because we are now in the process of updating it. So there will be a link to that, and also to the process which enables you to see how this is developing. This is what we set out to perform a couple of years ago. And of course, here you see the different areas in terms of cryptography, sensing, and other cloud applications in which we are enhancing scalability, range, reliability, robustness, while lowering the cost of these applications for quantum communication. So all of this is in much more detail in the document which you can find with that QR code, but it shows that really we are progressing here, and we are having already startups which deliver those devices, and you will see how we're implementing that in the real infrastructure. On the computing side, it's a different side. What I said before, if you send individual photons and someone tries to intercept them, the measurement will change the state, and we can detect, therefore, the fact that someone is trying to eavesdrop. In computing, it's a different advantage. Again, we are manipulating quantum objects one by one. Here, the advantage is that, unlike classical bits, which can be only in 0 or 1, quantum bits can be in superpositions. So it means that I can have, if I have one qubit, both possibilities. But if I have more qubits, more quantum bits, I can simultaneously explore all possibilities, all possible states. And if you can imagine of a simple example, like I am in a labyrinth and I want to get out of the labyrinth. And every time I have to decide whether I go left or right, I can assign a 0 or 1 value to the left or right. And classically, I would have to try one step after the other, one path after the other. But in quantum terms, with this superposition, in principle, I can explore everything at once. Of course, this is not something, and it is important to state, it is not something for which we really have a quantum computer solving, hexagon labyrinth, because not only you want the quantum computer to know what is the solution, but you also want to read it out. And if we just read it out, we will, again, in this simple example, disturb the state, so it will not give us a proper solution. So we need a much more sophisticated quantum algorithm, which will be able to achieve that, not only quantum parallelism, exploring all possible solutions, but also reading it out. We know only a few examples of such quantum algorithms, and indeed, now is the moment to really extend the possibility for people to access that, for users from industry and from science to be able to use that. And so here's an example from IBM from a few years ago, when they commercialized the first quantum computer. And then there is another example from Google, which is about the chip with which they did this quantum supremacy. So an experiment in which in 2.5 minutes they were able to perform a computational task, which at the time with the best supercomputer on Earth would take several thousand years. And now we start being frustrated because this is all coming from the US. But indeed, this was towards the beginning of our quantum flagship. And now we can proudly report that, as a matter of fact, we have world leaders in quantum computing and simulation in terms of startups offering these machines really as a result, as a spin-offs from our quantum flagship. This is an example of the company Pascal, which I'm citing here, just because, our Nobel laureate, Alana Spey, one of the 2 European Nobel laureates, which from last year in physics, is one of the founders and co-owners. So he's also a young entrepreneur because he's among the founders of Pascal, as a matter of fact, which is, delivering world-leading quantum simulators. So, I mean, here also we have a series of applications which you have to connect with different users. So it's about developing use cases for different applications in software, but also bringing forward the hardware according to the different platforms that we have. And also, of course, connecting this to high-performance computing, and we'll come back to that in a moment. Of course, this is not just quantum computing, but also simulation. Quantum simulation is special purpose kind of quantum computers which find applications probably in the shorter term in, practical problems, both, from scientific point of view in terms of, many body quantum systems, but also progressively in terms of quantum materials, and also, first simple, but in the future, hopefully also more complex chemical compounds, as well as in other fields which are relevant for industry, for instance, traffic flow optimization, and in perspective, other kinds of optimization applications, which, can in the long term, like 10, 15, maybe more years, also lead to applications in artificial intelligence. So, but this is not all, it's not just computing and communication, also sensing, using, again, individual quantum systems for measuring very, very precisely, states of some external system. It could be external fields, it could be a temperature of a system, it could be a gravitational field. Gravimetry is very important also in the upcoming plans of the European Commission. We're going to have in the Digital Assembly in Stockholm in 2 weeks from now, a live demonstration both of a quantum gravimeter as well as of first infrastructure for quantum communication, as well as of first cloud access of a quantum computer in Sweden. So sensing is one of the important parts. I just mentioned gravimetry, and also clock synchronization, which is very relevant for satellite navigation, as well as a lot of other aspects, for instance, in terms of microscopy and magnetic fields detection for medical applications. So really, it is a very diverse field of different applications, which are also coming to now maturity. And also the European Commission wants to start deploying, for instance, in hospitals for specific, advanced methods for diagnostics. So, this is the picture that we had in mind a few years ago, from a flagship to a fleet. You see in the center of this, we can see the flagship with the 5 areas, which I just mentioned. And this is, of course, very deeply rooted in the Framework Program for Research and Innovation, Horizon Europe, via our strategic research agenda. And of course, this would lead to several moon landings, so to say, in each of the different fields. But this is not the whole story, because of course we have also, for instance, in terms of a pan-European secure network, but also in terms of quantum navigation, quantum enhanced navigation via high precision time measurement, with the space program, of course. And so the European Space Agency is getting involved in that. Not only that, but also the Digital Euro program in terms of infrastructure, both for computing and for simulation in terms of, and for communication in terms of cybersecurity, is a very important dimension, which brings additional investment and additional opportunities also for our startups in there. Of course, there is a very, very prominent the issue of skills, in terms, in particular, digital skills in the Digital Euro program, which are necessary to bring forward all of these new initiatives. And this is not just happening at the level of the Commission, but also member states, in terms, for instance, of Quantera, the world's largest cooperation of national funding agencies, which is funding joint calls since already several years. Many calls they have funded. It will go on also in the next work program, in which those funding agencies, they pool the resources to fund different transnational projects of cooperation involving also all countries of the European Union. Not only this, but in specific topics such as metrology, there is Euromet, the European Association of Metrology Institutes, which is very deeply connected again to the metrology aspect and to all the applications such as, for instance, navigation and time stamping and all this kind of infrastructure, which is also being developed. And the European Space Agency I already mentioned, which is now becoming very active in terms of satellite deployment, both of quantum sensing as well as quantum communication activities, as well as, it was on the background, but it is coming more and more to the foreground, the aspect of international cooperation with such countries which now are called like-minded countries, such as Canada and also Japan and the US. Notably, there is a Trade and Technology Council dialogue between US government and European Commission, which is starting now with a working group devoted to quantum technologies. So really, we move from a flagship, you see here just the research part, in Horizon Europe, more towards what we could call a fleet with all those different infrastructures, which I will detail in a moment, really in the Digital Europe program, but also with the build-up of a quantum technology fund, uniting European Investment Bank, European Investment Council, and European Innovation Council in order really to provide an infrastructure for those startups to be able to thrive in the future. So this infrastructure dimension is really all about coming from the lab, the flagship itself, by enhancing reproducibility, reliability, by protecting intellectual property and European standards, bringing all of this to the market. And one important point for bootstrapping the market are initiatives in terms of infrastructures. For instance, EuroQCS, the European Quantum Computing and Simulation Infrastructure, in which we are now we have what we call the 7 sisters, 7 hosting sites in which, in supercomputing centers, there are the first quantum computers coming out and quantum simulators out of the flagship, which you really are able to perform, this enhancement as hybrid coprocessors in different platforms, to benchmark those platforms to be able to test and to develop new applications in terms of new use cases, which are going to be much more prominently developed. Not only that, but on the communication side, it's about integrating quantum communication, quantum cryptography, quantum key distribution into communication systems which are already existing both on the terrestrial and the satellite level, including indeed the European Space Agency, in order to provide protection for data, synchronization for clocks with very high precisions and a lot of other applications, in order to be essentially the starting backbone for a future quantum internet. And here I am very happy to show to you here that a couple of years ago we were able to show the first demonstration of quantum communication between 3 countries at the G20 in front of all of the ministers of research and innovation of the G20, between Italy, Croatia, and Slovenia, supported by one of our European startups coming indeed out of the flagship. So, but this, if we really want to keep up with the progress in terms of also, perhaps competition with the United States, it's very important to industrialize those technologies in a very strong way. So here is the important role of the CHIPS Act, the European CHIPS Act, which initially has been conceived for strengthening technological sovereignty in the field of semiconductor technologies, but now it has been extended. So we can happily announce that quantum chips have been included, thanks to the output of our quantum flagship. They have been included in the CHIPS Act in such a way that now we will have different lines of activities in terms of design libraries, pilot lines for developing those giving all those startups the possibility to really produce in small batches, an increasing number of such quantum chips which are necessary for all of these applications, and also testing them and experimenting and making them available in a broader way to all possible users. So here is the link that I promised before. So here is the current process which we are having of updating the strategic research agenda, merging it with the industry roadmap from our European Quantum Industry Consortium, which was mentioned also before, in terms of obtaining a strategic research and industry agenda. You can download the first executive summary if you use that QR code. And of course, by the end of the summer, we are going to have a much longer version, which is hopefully going to be taken up by the European Commission in order to sort of shape all the initiatives, also in terms of not only Horizon Europe, but also in Digital Europe, with the joint undertaking Euro-HPC on high performance computing, but also with Euro-QCI, the infrastructure on quantum communication, and also the activities in the CHIPS Act. We had a meeting a few weeks ago with the Commissioner Breton and the two Nobel laureates, in which the Commissioner really expressed his strong wish to move towards a comprehensive European strategy, which of course has to connect very deeply, very strongly with member states. So this is why we have an activity connecting with national quantum initiatives, which we have started now is going to become more official. And we are really confident that this input from the industry and academic community can be the basis further for well-informed decision for the future. So here's my final summary of the whole constellation that we have. I already mentioned the different components here. And I guess that this is the moment for me, after my given 20 minutes, to stop, to unshare probably my screen, and to look forward for your questions. Thank you very much.
Thank you very much, Tommaso. Just as a reminder, please use the Q&A window to send your questions and select the option send to co-host. We have already a couple of questions. One would be, do you think it is responsible to keep reiterating the quantum supremacy claim, although the community agrees it was an overstatement hype? In a similar vein, is it wise to speak of a fleet and thereby invoke militarily terminology?
Oh, I see. Okay. Well, certainly, it's very important to choose the proper language for